In this video we're looking at addition and subtraction again, but this time we're looking at it with slightly more complicated fractions where we've got more than one term on the top or on the bottom. The process is exactly the same as before though. We begin by multiplying the denominators. 3 times 4 is 12, and then we cross multiply. So we have 4 times by x plus 1, and then we're taking away 3 times by 2x plus 1. Going on to the next line, I want to expand both of these brackets because I might be able to simplify this top term. So let's have a look. That gives us 4x plus 4 minus 6x minus 3. Remember, this is negative 3 multiplied by positive 1 gives negative 3 all over 12. So I can simplify this top term now, the top expression, the numerator. 4x subtract 6x is negative 2x, and 4 subtract 3 is positive 1, and that's all over 12. Looking at this fraction now to see if I can simplify it in any other way. There's nothing more that I can do. There's nothing that's going to divide into 2, 1 and 12 other than 1. So we're pretty much done. We do have one option. We can reorder the terms in the numerator if we want to. So we could instead write it as 1 minus 2x over 12. Both this and this are completely correct. Neither one is necessarily better than the other. Quite often there's a preference to reorder in this order so there isn't a negative at the front. But then on the other hand, often the x's will be written before the constant terms. It comes down to preference. Here we have an increasingly messy, horrible looking set of algebraic fractions. We can add them together in the same way we've done up till now. Multiply the denominators together, and that gives us 8y cubed. And then cross multiply would give us 4y, 3y plus 2, add 2y squared, brackets 4y squared plus 3. As in the last example, we're going to expand the brackets to see if we can simplify this any further. So looking at this bracket first, we get 12y squared plus 8y. And then looking at this bracket, we get 8y to the power of 4, add 6y squared. And this is all over 8y cubed. Looking at the numerator first then to see if we can simplify this by collecting any terms together. We have a y squared term, a y to the power of 4, and another y squared term. So we can collect the two y squared terms together. And we can reorder this as well to put the highest power up front. So that would be 8y to the power of 4, and then 12y squared and 6y squared is going to be 18y squared plus 8y, and that's all over 8y cubed. Okay, looking at the numbers first to see if we can simplify this further. 8, 18, 8 and 8 all have 2 as a common factor. So we can divide all of these by 2. And then we have a y in every single term. That means we can divide by y. So that disappears completely. This becomes y to the power of 1, y cubed, and y squared. So in the end we have 4y cubed plus 9y plus 4 all over 4y squared. Okay, this example is a little bit simpler. We're going to get a quadratic, a trinomial on the bottom. If we multiply together the denominators, that would be x plus 1 times by x plus 2. And then cross multiplying will give us 7, x plus 2 minus 4, x plus 1. I'm going to expand all the brackets both in the numerator and the denominator now. So on top we get 7x plus 14 minus 4x minus 4, and on the bottom we get x squared plus 3x plus 2. We can simplify the numerator by collecting together some of the terms. 7x take away 4x is 3x, and 14 take away 4 is 10. And then on the bottom we have x squared plus 3x plus 2. Now, there could be a way of simplifying this further. With this particular fraction I know it won't work, and I'll introduce what that technique is in a later video. For now, there's no x there or there, so we can't cancel them out, and there's no common factor for all the numbers, so we're done. This is our final example. First, as before, we multiply together the denominators. Let's remember that this dot here means multiply, so this is actually just 2a written in a slightly more confusing way. So on the bottom we'd have 2a multiplied by a squared plus 3. And then if we cross multiply, we get 3 a squared plus 3 plus 2a times by 4a. So now I'm going to expand these brackets and multiply these two together and see if we can simplify it any further. 3a squared plus 9 plus 8a all over 2a cubed plus 6a. Just for my benefit, I'm going to rewrite this top line so that it's in order with the highest power first, plus 8a plus 9 all over 2a cubed plus 6a. Okay, looking at the numbers, there's no common factor that I can divide them all by, and while these four terms all have an a in them, this one doesn't, so I can't cancel that down either. As before, I'm aware that there is another technique which we could try to use to simplify this a little bit further, but I happen to know that it's not going to work on this occasion, so we're not going to look at it just yet. Instead, this is as simple as we can make it. Here's another couple of pairs of algebraic fractions. See if you can add together this pair and subtract this pair. Pause the video when you're ready to give it a go. Use either your mini whiteboard or a sheet of paper to do all the working. And then when you're ready, press play again, and the answers will appear one at a time.